There's a useful thing to note that there's a relationship between the class NP and the class of problems that are solvable in exponential time. Any problem that's in NP is also going to be solvable in exponential time. So the set of exponential time solvable problems includes NP. Now, by includes, I mean that it takes at most exponential time. None of the problems in NP can be any harder than that, say requiring double exponential time or factorial time or whatever it happens to be. They can all be solvable in exponential time. So if a problem is in NP, that means there's a bound on the size of the certificate needed. Say it's a polynomial n to the c for some constant that's specific to this problem, where n is related to the size of the input. And there is also a bound on the running time of the verification algorithm, like n to the k, where again n is related to the size of the input, and k is some constant that can depend on the problem, but it can't depend on the input. Well, if we have those two things, we can actually create an algorithm that can solve the problem for any input. So what it needs to do is we can just run through all the certificates that could possibly be relevant for input x. And for each one, we run the verification algorithm. And if the verification algorithm ever says, oh, yeah, that's something that shows that x is true, then we can return true as the solution for the problem. And if we run through all the possible certificates and none of them make the verification algorithm return true, then we can return false. And the running time of this algorithm is, well, the number of times we go through this loop is like 2 to the n to the c. If we imagine the certificate or the size of the certificate is written down in bits, this is the number of different assignments of bits to certificates of this size. So if we run through all possible ones of those, we know that we've checked everything. And then for each of those, the running time is on the order of n to the k. So the total running time is like n to the k, which is a polynomial, times 2 to the n to the c, which is exponential. So the total running time is exponential. It's not worse than exponential. It's not great. This is unless we're talking about problems that are really tiny, this is going to be horrible. But sometimes problems really are tiny, and mostly I'm introducing this as a way of just connecting these two concepts of the class NP and what it means to be able to run in exponential time. So it's nice to know that at least any problem that's in NP is solvable, right? We could write an algorithm that would run it. It's just that algorithm may take a very, very long time to complete.